All right, let's get started. Morning, everyone. My name's Ankit Asthana. I'm a program manager. I work on the C++ team, and I'm also being joined by Casey. If you guys probably don't know Casey, Casey's also the debugger PM. So she's going to have, you probably have a talk here too, right? So you should definitely attend her talk as well. So what are we talking about today here in this session is what's new with C++. So what we're going to get into is both Visual Studio 2015, VS 15, which is the next version of Visual Studio, and that's what we're calling it for now, Visual Studio Code, and a bunch of other things. So let's actually get started. So the way this talk is structured is that I'm going to spend a quarter of the hour talking about compiler and library. So this is going to be about where we are with our front-end compiler, where we are with the performance stuff, what's happening with the libraries front, what's new in the backend compiler space, and so on. This is going to be a little bit dry because there's going to be a bunch of slides here, but I'm going to make it up in the tools section by when I'm talking about Visual Studio and Visual Studio Code. There'll be a lot of demos there that we'll be doing, and in that section we'll talk about what's new from a productivity standpoint of view, what's new from a diagnostics debugging point of view, and so on. And the last section of the talk is basically structured about specific workloads that we have invested in from a C++ perspective. So that's about the, if you're building a Windows app, Windows Store app, the mobile story that you can do now in Visual Studio, the Linux targeting, IoT targeting, and also games. So does that sound good? To you guys? All right. So she's had her cup of coffee. That's great. All right. So I'm actually going to start with one targeted advert. So I hope you guys like it. So how many people here have had issues acquiring third-party libraries on Windows? Anybody trying to acquire Windows third-party library? Only one person has trouble acquiring a third-party library in Windows? Well, I don't believe that, but let's just start with this. So one of the things that we've been doing is, we've been looking at our platforms, and C++ is a true cross-platform language, and the acquisition experience for libraries on the Windows platform is not as good as some of the other platforms like Linux and Mac. So we've been experimenting with a solution in this space. And what we basically currently put on GitHub is this thing called VC Package, which is basically a third-party library acquisition tool. We've already preceded it with a bunch of libraries, but that doesn't mean that you can add your own library. You certainly can. What we're looking for at this point is that for you guys to try this out. If you guys have any feedback, reach out to us. Hopefully, if you want to contribute, that would be great as well. This is completely open source, and as long as you're building any Windows library, it's not tied to our compiler. It actually works for all the compilers out there. So the next section that I want to get into, and my slides led me there first, is the conformance story for C++. So within the last 1 year, we shipped VS 2015 RTM, and as a part of 2015 RTM, we shipped all these features in green across C++ 11, 14, and 17. And within the last year, we've basically shipped 3 updates. We've shipped update 1, update 2, and update 3. And as a part of that, we've also shipped more conformance features there. Now, recently, we've also been talking about Recently, we've also been talking about VS 15, which is basically going to be called the next version of Visual Studio. And as a part of that, we're working on implementing these features that you see in yellow. Now, some of these features that you might see here are, kind of like decorated with a double asterisk sign. And what that really means is that these features are basically hidden behind a compiler flag. And the compiler flag is called std C++ latest. So you have to throw that flag in order to be able to use these features. So one thing I do want to mention here, and might not be if it's not clear from this slide, is that within the next 1 year, as we prepare to ship the next version of Visual Studio VS 15, we want to be completely C++ 14 conformant. So that's something that we're driving hard for. Now, something else that's missing from this slide, can anyone take a guess what's missing from this picture? No conformance language standard fans here. So there's a section here missing about C++ 98. And the reason for that is that, as you can clearly see, there's no space on this slide. That's a part of my joke, but it didn't come out that well. But essentially, one of the features that we do know that people care about from a C++ 98 perspective is two-phase name lookup. And with 2015, we're also going to be adding support for this feature. as a part of the VS15 product. Now notice, just like the other features there, this feature is also decorated with a single asterisk sign. And what that basically means is that you got to throw another compiler switch. So let's take a look into what these compiler switches are and why are we trying to make your life difficult. So one of the things that you'll see here is basically that we do want to provide new language service features, like I mentioned in the last slide. But one thing that we've noticed is that when we provide these features and we enable them by default, it makes it a lot harder for you guys to be able to convert from one compiler version and update it to the next compiler version. So what we're trying to do here with these compiler switches is give you the control for when do you want to update to the latest conformance feature. We want to give you the control to be able to control the pace in which you want to up your conformance label for your code and so on. So one of the flags that we introduced is permissive minus. So this is basically the idea around this flag is that we want to basically make the compiler less permissive. So when you throw this compiler flag on the command line, it's actually going to go and start conforming to pre-C++11 standards. And when you throw this flag at this point, you can actually start using two-phase name lookup in the preview product. On that topic, the flag that I already talked about here is C++14 std:/C++14. So as I said, this is a screenshot from the upcoming VS15 product. And what you'll see there in the property page there is that this is kind of like our default setting from a conformance label perspective when you try out a new product. Now you can always control that conformance label using these switches, but that's really what we're after. And the last switch there that I want to get into as well is the std:/C++ latest. Now, C++17 is still being formalized, so and we've already started work on some of the features in C++17, and also some of the technical specifications for C++17s like modules and so on. So we basically needed a hood where to put these features under, and for now we're basically calling it C++ latest. Does that make sense on what these switches are and what they're doing? All right, so one of the things you can do when one of the things you can do is when you basically, when our compiler is becoming more conformant now is you can actually start using third-party libraries much easily because, previously they won't compile, but now they do. So this is a picture of the Seattle Public Library. We can't compile that. It's actually got a lot of information in it if you ever end up going to Seattle. But what we can compile now is basically Boost. We can compile Range V3, we can compile Google Test, which is basically for C++11. And this is just kind of like give you an idea about the kind of things you can do now as a result of the conformance work that we've been doing. All right, so now that I've given you a picture about where our conformance story is, something else that I want to share with you guys from a vision and a roadmap perspective is that as we are coming closer to being fully conformant with C++14 and also making headway in C++17, some of the other things that we want to take a look into and improve is our static analysis story, code analysis story, and our diagnostic story. So I don't want to make a big deal about this particular switch here, but this is kind of like a small step which shows you the direction that we're getting into. So if you throw this switch called diagnostics : caret, what it's going to do is that, as you can see from the picture, that it's actually going to give you not only the line number where the error is occurring, but also it provides you the column number information within that line number, which tells you exactly where the error is. So you can actually go ahead and try using this. Now, this is just a small example, and as I said, we're going to be making more progress here, but that's a start for us. Something's very fishy with this clicker. But anyways, so the next section I want to talk about moving from the front-end compiler is to the back-end compiler. And of course, you guys expect that every time we ship a new version of Visual Studio, it's going to be smaller and faster from a C++ compiler perspective, and it certainly is. And one of the things that we've done to make sure that this happens is that we've actually taken our backend compiler and rewritten major parts of it to now be SSA-based. And what this actually allows us to do is basically that it allows the optimizer to be able to do a better job in doing a reaching definition analysis, which is a base setting which many of the other optimizations like value propagation and code elimination and so on use. And you can see the results from the pictures here. You can see that some of the industry benchmarks like eigen and spec2k6, we see speedups there. And to the right of that picture, you can see the assembly code that's being shown there. And you can see the kind of code our optimizer was generating before we made this switch. and you can now see the kind of assembly code we're generating after the switch we made to SSA. So that's just an example of the work we've done there. Now, something else we've done here is basically that we've actually, we already spent a lot of time in basically making sure that our backend compiler and our frontend compiler are conformant, performant, and robust. And so far, we've been kind of like focusing and doing that by daily building Microsoft internal products like Windows, Office, Bing, Chakra, and so on. But starting very recently, our labs are also now daily building Chrome, Boost, OpenSSL, OpenCV. These are popular C++ benchmarks. So what this allows us to do is basically assess our compiler, make sure it's more performant, make sure it's correct, and so on. And some of these code bases are also cross-platform. So that also gives us kind of like a measuring bucket against how are we doing on throughput from a runtime perspective or a build time perspective against other compilers and other platforms. So if you have a big source code that you think is a good place or a good match for this, you can obviously reach out to us. We'd be happy to add it to our source repo there. If you have a large code base and you see some issues with correctness or performance, you can definitely let us know about that. The next thing that I want to talk about here is this compiler switch called guardcf. How many people actually have heard of this switch called /guard here? I didn't expect anyone to hear about this, but this has been a long secret that we've been shipping with. Most of the internal Microsoft products ship with guardcf. And what you'll notice here is basically that people use, so what the switch does is that it actually makes your source code a lot more secure. So what it does is that it's actually going to protect your code against against bogus indirect calls. As you can see in the example, a hacker might be able to control where an address return happens after an indirect call is made. And with guardcf, we basically protect against that. So if you have an enterprise product and you really care about security, you can actually build with this setting. All right, so the last section that I want to talk about in this topic is basically build throughput. So how many people here are currently happy with the amount of time it takes to compile your app or link your app and so on? Is there no one happy in this room with the amount of time it takes? All right, so I'm expecting that everyone's going to go and look into using these flags and these switches that I'm going to talk about here. So the first thing you'll see here, in 2015 Update 3, and 2015 to be honest, we've done a lot of work in order to specifically improve the edit build debug cycle. So that's real, and when you're talking about the edit build debug cycle, that's mostly about link time. How much time does it take to link your application? So one of the things we did is that we introduced a new PDB format, and what that does is that it significantly improves link time. If you take a look at the linker, most of the link time is actually, believe me or not, spent in creating the PDB file or the debug information. And this new flag that we're talking about here called debug:fastlink basically provides you out of the box about 2 to 4x gains. And we've measured this across a wide series of benchmarks, including Chrome, Bitmaps, and Fable. Fable 4s are Xbox One games. So there's only one caveat with this flag, which is why it is not enabled as a default setting in 2015 in your templates. And the reason for that is that when you're using debug:fastlink, what it does is that it produces a PDB, which basically does not have any private symbol information. And the debug information is distributed among the compiler OBJs and input libraries. So if you want to take the debug:fastlink PDB and put that in your simple server scenario, then that's the scenario that's not possible in 2015. But starting with Update 3 and VS15, we've basically also integrated a tool as a part of the project build menu, which will now allow you to be able to build a full PDB from a debug:fastlink PDB. So if you're inside Visual Studio, you won't see any impact at all. If you want to be able to share that debug:fastlink PDB on a simple server or copy it to a different machine, you can then use this new UI option that we've added, which we'll call the special tool, which will produce the full PDB, and there you go. But I would really recommend you trying this out because this basically makes a huge difference in your link time. Now, something else that I want to talk about here is basically, we recently, in 2015 timeframe, also announced a partnership with Incredible. Now, has anyone heard of Incredible here? All right, at least I see a few hands here. So Incredible, for those of you who probably are not as aware of Incredible, it's basically a software acceleration technology. It allows for you to make your builds really faster and so on. And what we've done in 2015 is we entered into a partnership with them. And when you're using Incredible, once you've installed Incredible from within Visual Studio and you're using Incredible, you will see out of the box about 10 to 20% improvement all up in your end-to-end build. And the reason why you'll see the speed up is because when Incredible actually goes and generates an improved build plan, which basically breaks down fault dependencies. So normally, MS Build, if you have a solution and it has a couple of projects in there, it creates a build plan, versus Incredible creating the same build plan. Incredible will be able to do a better job there by breaking down some of the dependencies, which are not really real dependencies. And the second thing Incredible does really well is that it actually has a resource manager. So what that does is that it's able to look at your hardware specs, and it's able to tell that, oh, look, you have 8 cores, or you have 16 cores. And based on that, it can actually increase the level of parallelism from a compiler perspective, or it can actually decrease the number of compiler processes that are running in parallel, all in all, resulting in the speed up that I'm talking about there. So if you haven't tried this out already, you should definitely go and try out the Incredible extension. Is there any questions there so far on the material that I've covered? That takes care of kind of like section 1. Nobody has questions on the stuff. Everybody's happy. Everybody sees all the features that you expect to see. All right, that's good. So the next section that I'm going to get into is going to be about tools, which is basically 3 tools that we have now in the Visual Studio family. I'm going to talk about Visual Studio, which is basically our developer IDE that you guys use every day. Something else that we've released very recently is Visual Studio Code. Visual Studio Code is a new code editor, and it also supports C++ now. How many people here have heard of Visual Studio Code? All right, great. So we're going to be doing a demo there. We're going to talk about some of the features there and so on shortly. The other thing I want to get into is basically Visual Studio Team Services. So one of the things that, if you guys are not aware of Team Services, is that this is basically a service that we have. It's independent of the IDE you're using. You can actually integrate your source control. You can also manage your projects better by using Project Kanban or dashboards and so on. So if you haven't given it a try, you can actually learn about it more at visualstudio.com. So with that, I'm actually going to do a quick recap in terms of what did we ship with our RTM product and what we've done since then in update 3. And as you'll see there, we've done a bunch of work in our productivity and our debugging story. So from a productivity perspective, we've done work in order to improve our IntelliSense story. We offer now single file IntelliSense. We also have a new database format which allows us to allows better scale for IntelliSense. From a refactoring perspective, we added a bunch of features there like rename, extract function, which we'll be demoing. We also added some quick fixes. And then we've also done a bunch of work on debugging, and Casey's going to demo this soon, so I'm actually going to let her do that. But if you guys want to learn more about what's new with 2015 and what you haven't seen so far, you can basically go and review our Channel 9 talk that we did at Build this year, which gets into this in a lot more detail. But that's kind of like the short story there. So with that, I'll probably get into my first demo, which is going to show you some of the highlights of these features. I do have time to take a couple of questions, unless you guys, as I'm setting this up. All right. Can you guys at the back read the code there? All right. So here I basically have, let me just sign out here. Sorry about that. So here I have Visual Studio 2015. And one of the things that I'm going to show you next is the set of productivity features that I just talked about. So in order to be able to follow this, you should basically first go and enable these features. Some of these features are still experimental. So if you bring up the Tools Options menu and you look under Text Editor, C++, under the experimental section, make sure that these things are set to true. We're still working on baking this into the product itself, but as you can see, they're still usable in 2015 Update 3. All right, so here I basically have a very simple Azure storage application. All it does is basically it creates a turn-based multiplayer game, tic-tac-toe, and I'm going to be using this to demonstrate some of the productivity features. So let's just take a look at a little bit of code here. All I'm doing here is basically setting a connection string. Then I go and create a bunch of queues, which basically control the state of my game. And finally, I go ahead and ask the user for his player name or player credentials. Finally, I take this player name and I create an Azure Storage queue message out of it. And eventually, I actually go ahead and add that queue message to my event queue. And what this is basically doing is actually initiating my game for being able to know the fact that there's a user that's actually logged in. So the first thing I'm going to do here is that this piece of code pattern that you're seeing, where I basically add a message and then I download the attributes of this queue, this is a code pattern that I'm actually following a lot in this piece of code. So what I want to be able to do here is basically extract this as a function. So starting with 2015 update 3 and the experimental feature that I just showed you, talked about, what you can do is you can actually enable this by hitting the control dot key, or alternatively, you can actually right-click this piece of code and say, I want to bring up the quick actions and refactorings feature. And what this will allow you to do is it will give you a bunch of menu options here to control the refactoring that you want. In this case, I want to go ahead and extract this as a function. This will give me this UI here that comes up now gives me a view of the function or the method signature for this particular type. In this case, I'm actually just going to go and call it add queue message and click OK. And as you can see, this actually created a function now called add queue message, and it also created a function call from this particular call side. So let's go and just inspect this a little bit more by using the go to definition feature. And here we go. That's the function that got created, and this is what we expected to see. So that's the first refactoring feature that you guys can use. Now, let's imagine that the event queue download attributes. Let's imagine that I don't always want to do that, and I only want to do that on demand. So what I want to be able to do then is that I want to change the signature of this method to now allow an additional parameter that tells me whether I should go ahead and download the queue attributes or not. So what I'm going to do is I'm actually going to use the next refactoring feature here called change signature. And what this will allow me to do is this will actually allow me to change the signature for this method. In this case, I'm going to go ahead and add a new parameter type. So I'm going to add a new parameter called of type Boolean called download attributes. And click OK. And as you can see, that will basically add another parameter to my function signature. I'm going to click OK. It's going to give me this view where I can go ahead and preview all my changes. So let's just go ahead and take a look at that. As you can see, this is the first call side. And at this call side, what it's done is that it's actually added space for another parameter type. And at the second call side, what it's done is basically changed the function signature to now include the bool download attributes parameter as well. So I'm just going to go ahead and click apply and hope everything works out. So as you can see, the extra parameter was added to the end of the function signature here. So let's just go ahead and use it now. All right. And now we basically only have one more thing remaining. So I can go back now to the function call side, and I can actually go ahead and add a parameter type. Now notice how this is a new feature that we have added as well. This is called a quick fix. So as you basically hover over the squiggle, it will basically give you a set of suggested actions or potential fixes. So in this case, it basically tells you that there's actually a parameter missing here. So I'm actually going to go ahead and add true here in this case. And there you go. That's going to take care of that. So as you can see, this is fairly easy to use. You guys should definitely try to make use of this. I do have to say it's somewhat experimental still. But I've just showed you two refactoring features, extract function and change signature. Now something else that we've done in 2015 RTM and update 3 timeframe is basically added this feature quick fixes. So let's go ahead and demo that. So how many times have you run into an issue where you forget to basically add a semicolon? Especially on a Monday morning after a long weekend and so on, and you're writing your code. So now one of the things that will help you out here is that with this quick fix feature, it will actually suggest you a bunch of potential fixes. So as you can see in this case, it's basically telling me that, I expect a semicolon. So I can basically go and say that show me potential fixes, and it's going to tell me, well, add a semicolon at the end of the previous token. And there we go. Well, not quite. A small bug here, it seems. So let me just delete that. Let's try this again. As I said, it was experimental. So here we go again, and here we go. All right, so we have working code again. So the next thing I want to show you is basically another quick fix feature. So how many times have you guys started coding and realized that you didn't have the right include? So the next quick fix actually, is going to be able to add includes on demand as a part of the potential fixes. So as I mentioned that this is a turn-based multiplayer game, and in this piece of code here, basically, there is a player turn toggle here. And let's say that I want to go ahead now and add a game timer here. So I'm actually going to go delete my include right here to make that work. And actually, while I'm at it, I'm also going to remove my namespace std. That's going to create a bunch of errors here. So the first thing I'm going to do, as I said, is that I'm going to go ahead and add a game timer here so that I can actually time how much time it takes me per player turn. And one of the things you can see now is that quick fix will come to my aid, because it will actually show me that, you know what, you're missing this include. And I can actually go ahead and add that include now, and everything else will be fine. Likewise, I actually removed the namespace std include there, so you'll see a bunch of errors there. And again, you can use show potential fixes, and it will tell you that, oh, you want to go ahead and add you want to go ahead and add namespace std because that's what's currently missing. And once you use the potential fix, it's actually going to go ahead and add that for you. So these are some of the features that we've added for, to make you more productive as you're coding. Now, something else that I want to demo as well here is that, now let's imagine that I want to basically say number of messages in my queue. In queue, and I go ahead and I put a really large number. And let's see what happens now. It's going to complain, that's right. So one of the other things you can do here using the quick fix solution provider is that you can also actually query a search engine of your choice and figure out if there's a common issue that someone else is facing. So I can actually go click this, and it's going to then start a web search, bring up the browser, and try to find you help as and when you need it. All right, so let me actually do that. So that's going to basically launch a web page, which is basically right here, and you can see that it actually provides you some help here in terms of Stack Overflow issues where the integer constant is too large. So you can use some of these features here as you're writing your code, and you can benefit from it. Now, something else that we've also done, and again, this is in update 3, is we're going to be able to provide you help in order to create function definitions and declarations automatically. So just imagine that I go ahead and I add a new timer here. So I add a function called pause timer here in this game timer.cpp. So it's going to complain because this is basically not defined or not declared in the header file. But what I can do now again is I can use the quick fix that's provided me here and create a declaration for pause timer in gamer timer.h. And you can see there, as I use this quick fix, it actually goes and adds the declaration for this particular type in the header file. So that should give you an idea about some of the quick fixes that and some of the refactoring features that we have in the product. Now, again, this is not a wholesome list. There's a lot more than this. But this is something just to give you guys an idea about the kind of work that we've been doing. So for the next section, I'm actually going to ask Casey to help me out here, since she's a lot better than I am in this, and show us some of the new productivity and debugging features that we've shipped as a part of 2015 Update 3 and 2015 RTM. Casey, it's all yours.
Hey, thanks, Ankit. Can everyone hear me okay? Good, I see nods in the back row. So let me just log into my machine here and switch over so you can see my screen.
There we go.
Good deal. Is that big enough? Can you read that in the back? Yes, gentleman on the back.
Sorry.
Thanks, Ankit. Oh, did I bust? Is this still on? Okay. Okay, guys. Just for my own benefit, how many of you are currently using Visual Studio 2015? Raise your hand. Okay, that's a lot of you. How many are not? Okay, a little less. About half, actually, though. Good morning, guys. So I'm here to talk to you about the debugging features we added in Visual Studio 2015. So I have this application here, and all it does is it's a simple guess number app that when I make a guess, it'll tell me too high or too low. So I'm going to make my first guess here, put in 0, and it says input must be an integer. And that's a little strange to me because I know 0 is an integer, you know 0 is an integer, why doesn't my application? So I'm going to go to the output window, and when I look here in the output window, I can see that there was an exception thrown in my application. And instead of maybe going through and commenting out all my try catches to figure out where this exception would become unhandled, I'm going to go to the new exception settings window. So this is under Debug Windows, and it's exception settings. And this is the place where you can come to turn on exceptions to break when thrown. So essentially, when you check boxes next to exceptions in here, you're creating an exception breakpoint. This capability is available in previous versions of Visual Studio, but we made it a non-modal window here. It used to take like 6 seconds to load up. And we added a respectable search. So here, if I type in STD, for example, you can see that I have the standard exception, and I can turn that on to break when thrown. So now, when I retry this and hit 0 here, I get my exception to break. So I have to dismiss this dialog and click break, and it shows me the place in code where my exception's occurring. And as I just scan through this line of code here, I'm seeing that basically it looks like I'm not accounting for the fact that my string is null terminated. So I'm going to go ahead and use another feature called edit and continue to go ahead and add some logic here. So if nums of x is null, we're just going to break. Not muns, nums. Then we're going to break. And so who here has used edit and continue before? Couple people, okay. One of the reasons you might not be using edit and continue today is because when you, in previous versions of Visual Studio, when you turn it on, we'd have to fall back to the 2010 debugger, and you'd lose out on a lot of good language features that have come in since that. Well, in 2015, we revamped edit and continue, we put it back, and we made it work. We made it work with things like FastLink that OnKit mentioned earlier, and we've made it work with x64 processes. So you can see right here in the toolbar, it's very faint because it's grayed out right now, but you can see I'm debugging an x64 process. And so I just made my edit to the code. It's still running. When I hit continue, my application's going to recompile, and we're just going to wait just a second for that to happen. And as soon as it's done recompiling, it's basically applying those code changes right now. And when I try my, I don't have to stop and restart my application. And now when I make my guess again, I no longer break on that exception. And it tells me that this is too low. And I didn't have to stop and restart my application. So that's supposed to help increase your productivity in the inner debug loop there. One of the other things that's new in 2015 that we added, I'm going to go ahead and set a breakpoint. I'll set it right here. Set a breakpoint there, and just make another guess. 0, I guess, is my favorite number, and so I'm just going to keep guessing it. And I hit my breakpoint here, and when I examine this guess result, this string does not look too friendly readable for me. I've got a lot of data in here that maybe I don't necessarily care about. I'm going to go ahead and add this to my watch windows so we can see it a little better. If I right-click on the variable and then click Add to Watch, it'll show up down here in my watch window. And when I drill in on this, you can see that I have a guess, and I have a server result, and I have some binary data. What I want to do is visualize this a little better. So who knows what a NatVis visualizer is? Has anyone used that before? Just like one person. OK, so I won't get into too much detail about what NatVis is. I encourage you to explore that a little more. But the basic definition is that it's a way to visualize, it's an XML-based way to visualize your native types. So we've included this my.natviz file here in the project system. Previously, this would have to be, you'd have to find this in the program files of Visual Studio, but we've brought it into the Solution Explorer here. And when I open this up, you can see that it's just a way to define how you want this displayed. And I'm still under the debugger, and when I uncomment this out, you can, and I hit save now, watch the watch window, and you'll see my guess result update to a simpler string that what I want it to be. So this comes in handy a lot when dealing with complex C++ objects that you just need a quick handle on what this object means and what it is. So NatVis files that are supported. And because it works on save, if your visualization isn't quite right, you'll see that quicker, and you don't have to stop and restart your debug session to see those outputs. Okay, so that's NatVis. So I'm going to go ahead and, continue here. And I'll show this real quick, and then we'll come hit it again. This right here is a new adornment that has been added in 2015, and we call it a perf tip. So right now this number's large because I was in my application. So when I move my instruction pointer back and take another step over this, for example, I just used the set next statement feature, so you can drag the yellow arrow up and back. And that has side effects, but in this case, I know it's going to be OK. So when I hit continue to hit this breakpoint again, you'll see that my perf tip shows up here with the time it took to complete that last step. So perf tips are basically order of approximation. If I come back here and step in to guess number, you'll see that it only says less than 1 millisecond elapsed. So the difference between 1 millisecond and 2 milliseconds, if that number was 2, doesn't mean it's twice as slow. But if you have 1 millisecond versus 40 milliseconds, there's a difference in processing there. Something's going on. So when I was taking that step, I'll go ahead and set a breakpoint here, or unset my breakpoints for a second, and so we can feel how slow this might be. So as I was typing here, I was feeling that this takes a little slow. You can see the delay a little bit. So in my perf tip, I'm going to use my perf tip to try to figure out what's going on there. And let's go back to guess number. Whoop, can't see my keyboard a little bit. OK, so we'll go back into guess number, and we'll set a breakpoint here. And we'll come back around and hit that. So now I've hit this breakpoint. You can see my perf tip. And because I'm stopped at that breakpoint, I can run from breakpoint to breakpoint. So perf tips don't just work between steps, they work between breakpoints. So I can time basically this whole function by running from breakpoint to breakpoint. And it says that whole function took around 874 milliseconds. So now when I come back around and hit this breakpoint again, I have to hit continue first. Oh, and I keep hitting my breakpoint. Sorry, guys. OK, so we'll hit this breakpoint again. And now we're going to just step through the function and look at the perf tip change. And when I step over build query base, I see that that took quite a bit of time. And so I'm guessing this is where my problem is, but I kind of want to confirm that now. So another new thing we added in 2015 is the diagnostic tools window. So who here has seen the diagnostic tools window? It looks like this. Yeah? Some hands? OK. Who here has closed the diagnostic tools window? A little bit more of you. So you can get that diagnostic tools window back anytime by simply clicking on the perf tip. And what the diagnostic tools window has is it has an events track that keeps track of every time you enter break state. And your breakpoint and your step. And this duration column here, this is the history of your perf tips. So as you're stepping, if you're like, oh, what was that last perf tip I took? You can come to the events tab here and see what those values are. We also have a memory usage tab, which I'll get to in a minute and we'll talk about. And then there's the CPU usage. So when I am collecting CPU information, we get a call tree displayed here, and I can see where a lot of the time is being taken. So as I drill down here, in guess number is taking most of the time, and specifically in this build query base, like I figured out with the perf tip. So what's going on? Basically, it's doing a bunch of string concatenation, and so I'm paying that every time I guess a number. I don't really need to do that anymore. I don't really need to do that every single time. So I'm going to try to use edit and continue again here. And instead of calling that build query base every time, I have a variable that I initialize once that I've already set ahead of time, just called query base, that will call that one time. So now, when I hit continue, it'll recompile using edit and continue again. And I know you're C++ developers, you're kind of waiting on things to compile sometimes, right? We're all used to this. Everyone's laughed a little bit. OK, good morning, guys. So it's compiling and applying. And as it does that, as I hit 0 here, you can see that it's much more responsive and fast. How long is it now? Guess what? We can find out with that very same perf tip. So as I come hit the breakpoint, I can quickly verify that when I step over this now, it's less than 1 millisecond elapsed. And if I want to time the whole function just to make sure, I can hit continue, and the whole function now takes 21 milliseconds. So perf tips are a really easy way to get a quick pulse on maybe what's happening in your code, where things are taking a long time. Who likes the perf tips? Yeah? Good deal. Good deal. So I mentioned memory usage. So back to the diagnostic tools window. I was looking here, and I was seeing a bit of a spike in memory. Every time I would make a guess, I feel like this number keeps creeping up there. And in my mind, I'm going, wah, wah, that means I probably have a memory leak. So the diag tools window is cluing me into that. I'm going to enable heap profiling. And we don't have heap profiling, so this is the memory usage details. We don't have this on by default because we're tracking every allocation. So there's a little cost to maintain this. But when you need it, you can turn it on, and then you could just keep going now to do your memory profiling. But what I'm going to do is I'm going to restart. I've done edit and continue. I don't exactly know what state my machine's in, and I kind of want a clean baseline here. So I'm just going to restart my debug session. And I'm going to take a snapshot of just what the base of my application is. And I did that without being stopped at a breakpoint, just while my application's running here. And I'm going to unset that breakpoint and go back up to my game loop, down to my game loop, and set, let's go ahead and unpin this so you can see a little better. I'm just going to set a breakpoint right here again. So now when I come and hit this breakpoint after I make a guess, I'm going to take another snapshot, and that was not the right place in code. Because, well, maybe. OK, so what happened was I was stopped at the breakpoint, and I took another snapshot. And you can see that there's a difference between the first snapshot I took and the second snapshot in the memory usage tab here. So it shows me that I went up by 655 kilobytes here. And I clicked on that, and it opened the snapshot view that gave me a breakdown. And I clicked on that to see, for here I can see that this G result is where a lot of my memory is going. And there's this little icon right here. You probably can't see that all the way at the back. But when I click on this, it gives me the instances of G result here. And because I'm stopped at a breakpoint, when I hover over it, I can inspect that object in memory. And so that's the benefit of taking a snapshot while stopped at a breakpoint, is that you can use data tips to inspect the memory. So when I right-click on this, I'm clued into this is my issue. So I can right-click and go to the source code to see exactly what line of code where this is being allocated. And as I scan through this, I can see that guess result here is allocated, but never returned. Nope. What I can see here is that guess result is being returned, and it's being passed up the call stack. So back in my game loop, I'm getting the guess result back. And here's where I'm using it, but then I'm never releasing it. So I will go ahead and add delete here, and I'll delete my guess result. And I will set it to null just to be sure. Save this. Whoop, if I can spell null. Save this. And now I'll hit continue. Or we could have restarted, either way. And I'll take another snapshot and then show you that the memory stopped changing as drastically as it had done before. So back here, I'll take another snapshot, make my guess again, make maybe a couple more guesses just to see, and take another snapshot. And now you can see that in 3 snapshots, the memory did not increase as much as it did with that one. And when I zoom out a little bit and look at my graph, every time I make a guess, the memory isn't increasing and climbing anymore like it was the first time. So I was able to use the Diag Tools window to help diagnose my memory leak there. Cool. So is there any questions about the Diag Tools window before I move on? Yeah? So it works with managed debugging, so .NET debugging, and it does work in mixed mode. There's a couple caveats when you're using it in mixed mode, but we try to make it intuitive to help figure that out. Cool. Any other questions about the Diag Tools window? Yeah. Does it work with the remote debugger? Off the top of my head, I want to say yes.
Yes.
Yes. Okay. OnKit says yes. Yeah, it does work in that scenario. Okay. I'll just want to show you 2 more things that we added. I won't do a super big demo here, but every time I set this breakpoint, can you see this toolbar that appears next to the breakpoint? Has anyone ever clicked on this toolbar? When I click on it, it gives me breakpoint settings. So in the product for a while, you've been able to set conditional breakpoints and trace points, but we redid the UI in 2015, so it's in a non-modal window, and it becomes easier to copy and paste from your code into here if you need to set like a conditional breakpoint or a hit count breakpoint. So anything that evaluates to a Boolean goes in there. And then for actions, this is a trace point. Have you heard of a trace point before? Not really, some people. So what a trace point does is instead of writing debug.writeLine or console.writeLine and actually editing your code, you can set a trace point to print output to the output window without modifying your code. So if I type text in here, the text will get printed, and I can use curly braces to print out values. So if I printed guess result inside the curly braces, the value of that gets printed out, and it becomes a diamond. So this breakpoint actually does not stop at your code, so it traces, and it'll print that output in the output window. So that's breakpoint settings for you. And the last thing that I want to show you, I'll just make a guess of 101 here. And you can see that in this exception message, I see guess result, server result was garbage. And basically, for access violations, what we've done is we've pulled out for you in your exception message what is basically null, what is garbage that's causing your access violation. So we've tried to make it easier for you to diagnose those things just in the exception message. And do I have 1 more minute, Ankit?
Absolutely, yeah.
Okay, cool. So C++ doesn't get a lot of love sometimes from the platform, right? A lot of times we focus on .NET, and like Ankit was saying, I'm giving a debugging tips and tricks talk on Thursday, and we geared that towards .NET developers. But for you guys, hopefully this will make you happy. I'm going to switch over here to VS15. This is the preview version, like Ankit was saying. And one of the things that bugged me every time I use C++, and I've heard this from several customers too, I don't know why my build isn't successful.
You might be running the app in the other VS instance.
Oh, yep. Good call. Thanks, Ankit.
No problem.
It's why it's good to do demos so it doesn't become a demolition, it just becomes a demonstration. Okay, so this is building. Okay, so I'm going to do that same thing again and make a guess of 101. Boom. And what happens is now I don't get that modal dialog in my face anymore. I don't have to dismiss it with continue, break, ignore. What do those even mean anyway, right? So I am seeing my exception message in a non-modal window in line with my code, and we're trying to save you that step of clicking. And here you can see that server result gets bolded. This tells me immediately what was garbage and causing my access violation. So hopefully, and if you need to, you can drag this away, pin it, and have your floating dialog again, but now you can see your exception message even when you're stopped at your code and you don't have to dismiss it or copy it or things you might have done before. So I'm going to ask, who likes that? Is everyone cool with that feature? Cool. Thanks, guys. I appreciate it. So that's what I wanted to show you about the debugger. I'm going to pass it back to Ankit. Come on up. And was there any last-minute questions about debugging things in 2015? Yeah. Can you? It's not supported today, but I hear you. He asked, can you get IntelliSense inside trace points? And so that's not supported today, but maybe in the future. Thanks.
Thank you so much, Casey. All right, so I'm going to have to go back a little bit in time here. So yes, sir.
Before you go on, when you refactored and added a parameter,
Yes.
could you have made it have a default value?
Yes, you could have actually.
And that wouldn't have had the commas to take care of?
I believe so, yeah. There was a setting there when you add a new parameter. There was an option there to add a default value. You can use that to make that work. All right, no problem, yeah. So I'll keep going. So the next thing I'm going to talk about, we're going to segue away from Visual Studio for just a minute. And we're going to talk about Visual Studio Code. So some of you here said that you guys have tried Visual Studio Code. For those of you who haven't, Visual Studio Code is a new text editor plus a pretty slick debugger. It's cross-platform, it's free, it's got a bunch of code editing and debugging features, and you guys should really try it out. And to be honest, instead of me talking about the features, I can actually just go ahead and demo this. So I'm just going to wake up my machine and bring up code here. All right, you can do this. So here we go. So I'm actually going to transition from VS to VS Code for a second. So here's Visual Studio Code. Let me just actually close this folder so it gives you a better view. Come on. So by default, it has a few tabs on the left. The first tab is about your source code. The last tab is about installing new extensions. So VS Code doesn't actually come integrated with C++. What you have to do is you have to go to the marketplace and install the C++ extension. But that's really easy to do. I can just go to this extensions tab here, say C++ or CPP tools, and that's basically going to bring up this extension. As you can see, I already have this installed. And as you can also see, we're actually pretty popular now. We have about close to 400,000 downloads, and it's only been 4 months of us shipping this. When you do click on this extension tab here, what you'll see is this README file. The README file is, we try to keep this up to date. So it's going to give you a picture of what's new with the language service and debugging feature point of view. It will also give you a change history on what we change every month. So far, we've basically shipped every month updates to our extension, which are new features and bug fixes. So we're really trying to create a community here that's live, and we're really trying to make sure that your feedback is heard and taken into account. So with that said, once you've actually installed the C++ extension, the next thing to do is basically open up a C++ source code folder. So this is what's actually different than what you'll expect and see in Visual Studio 2015, where we currently ask you guys to go create a Visual Studio project before you can start using Visual Studio C++ experience. Now we're changing that in VS 15, but let's get back to VS Code here for a second. So what I did just now is that I opened up a C++ source folder, and I'm just going to bring up a source file here. Out of the box, what you'll see here is that pretty much a good set of your code editing features would just work. For example, I can do things like peak definition on this guest server type. It's the same application that Casey was showing you. I can also do things like go to definition for that particular type. And this is just happening out of the box for you as you open the source code folder. So what's happening in the background is that as this folder gets loaded, our language service engine goes ahead and parses all these different symbols, put that into a symbol database, and starts empowering these code navigation features based on that. The key difference here is that you don't really need any project. This would work for Visual Studio Project on Windows or Ninja Project on Windows. It will also work for your make files and even just random C++ code without a project build currently present. So you guys should definitely try this out. A couple of other features here is that we have this preview feature for autocomplete. So what you can see here is that as I start typing, the preview autocomplete feature gives me the suggestions that I can use when I'm writing my piece of code. Something else I can do here is things like code format. So I can select a piece of code or the entire document. So in this case, I'm going to select just a piece of code here and click Format Code. And that's going to take care of formatting that piece of code. And for formatting code, in the background, we're basically using Clang format. And Clang format gets auto-installed as a part of the acquisition experience of this extension. I didn't show you guys that in the interest of time. But as you install, when you're going to install this, you're going to see this happen. Now, something else that you can do with Visual Studio Code is that you can also call external tasks to build an application. So let me go ahead and show you guys that. In order to do that, what you need to do is bring up the command palette, which is basically just Control-P, which is going to bring up this menu, and I'm going to go and say configure a task runner. And what this configure task runner does is basically allows me to call an extensibility task. Visual Studio Code already comes with a set of prepackaged task runners. In this case, given that it's an MS Build project, I'm just going to click MS Build, and that's actually going to go ahead and create this task.json file. So the only other thing I need to do now is basically provide the name of the solution that I want to build, since there's a couple of solutions here. And I'm going to go look in my cheat sheet here on what the solution is called. Here we go. I'm going to add a comma here. So this is the JSON file. So again, this is a task.json file. When I now initiate or run this task, what's going to happen is that it's going to call MS Build with those parameters. So let's go ahead and do that. For doing that, again, I'm going to bring up the command palette. This time, instead of saying configure build step, I'm actually going to say run build task. So I'm actually going to do that here. That's going to bring up the build menu. As you can see, the application is getting built. So that'll just take a minute or two. So in this case, I showed you this for MS Build, but you can pretty much use this for calling CMake or Ninja or any other build system that you might actually be using for your source code. So as you can see, the piece of code was built, and that's great. So far, I've shown you editing and building. Now next, I want to also show you some of the debugging features that Visual Studio Code provides. I'm not going to get into in too much detail, but one of the things that you'll see is that we actually provide debugging not only for Windows PDB Classic Visual Studio applications, but we also provide debugging for MinGW and Sigma application on Windows. From a debugging perspective, we also support debugging on Mac and Linux, and we support both GDB and LLDB from a debug engine perspective. So like I did for setting up the build story in Visual Studio Code, and I create that task.json file that you can view on the screen right now. In order to debug this, I need to create another file called a launch.json file, which basically has a set of debug parameters that I could use. So I'm actually going to click this gear option, which is basically going to bring up this menu. This menu is going to give me a choice of which debugging engine I want to be able to use. Since this is a classic Windows PDB application, I'm actually going to go ahead and say C++ Windows, and that is going to create a launch.json file. And this JSON file is basically created with two configurations, launch and attach. So you can actually either launch the application and then launch the debugger as you launch the application, or you can actually attach the debugger to a running application. And just like you do in Visual Studio, you can actually choose between these two configurations using this menu here. So the only thing I need to do now in order to be able to debug this application is provide the path to it. So this is the path to the exe. And again, I'm going to go and cheat here in the interest of time, and provide the path to the application. So that's my exe that I want to debug. And since this is a console application that Casey was showing you, I'm actually going to set this to true. Now, all I need to do to debug is to go back to my source code, and I already have a breakpoint set. That's great. And I can actually click launch. So I'm going to go back in the debug menu, click launch. That's going to launch my app. And as you can see, the breakpoint that I set was hit. Now, pretty much all the features that Casey talked about, you can do that here. You can, you could step over. You can go ahead and set expression evaluation. You can look at the call stack, breakpoints. The whole shebang is actually present here as well. The other thing I can do is I can also do conditional breakpoints. So what I need to do for that is click the breakpoint, say edit breakpoint, and then add the condition here. So out of the box, you guys can see how you can use Visual Studio Code, which is cross-platform for doing a basic editing, debugging, and also call external tasks via the task extensibility mechanism to be able to build your application. Does that sound good? Is there something new that you guys learned, people who are using Visual Studio Code here? But that's basically, that's what I had for this demo. Is there any questions on this Visual Studio Code perspective before we move back to Visual Studio? No questions there? All right. I think that's a very good question. The question is, why would we use Visual Studio Code instead of VS or Visual Studio? It's probably because of, there's two kinds of users that we see. Some people tend to be more text editor savvy, like Vim and Emacs and Sublime. So if you're in that world, this is a great pairing tool along with Visual Studio on Windows. So if you want to open one source file, or you just want to basically, you like editor workflows better, you can actually use Visual Studio Code. So that's one reason on Windows. And a non-Windows scenario, Visual Studio today doesn't run on Linux and Mac per se, not for the C++ workload at least. And so if you're working on Linux and you want to be able to debug your app, or you want to write code on Linux, then you can use Visual Studio Code there, and you can also use it on Mac. So that's basically, what I would recommend. But you're absolutely right. This doesn't have the same richness from a feature perspective, but it is a pretty slick editor. And for now, yes. So on that very point, I'm actually going to, push back here on my slides, since this demo is over and I've lost my clicker. So the next thing I want to talk about is VS15. So I showed you guys, Visual Studio Code. And what you'll see there is basically some of the things that are good about Visual Studio Code. We're also trying to, make VS better from that perspective. So performance or resource usage was just mentioned. So one of the things that we've done is we've actually spent a lot of time in improving performance of Visual Studio 15. This is the next version of Visual Studio again. So one of the things you'll see there is that for large projects where basically you don't have a PCH defined, what used to happen is that IntelliSense in some cases might be a bit slower. And now we basically optimize IntelliSense even though if there's no PCH defined. Likewise, for one pathological case, I believe this is the Unreal Engine. In Visual Studio 2015, we were running out of memory. We weren't able to debug it. But now we can contain that process within 2 gig. Something else we've done is basically we've actually spent time improving the solution load performance. So what you'll see here in this picture is basically Chrome. And Chrome is like a really large solution there. It has about 1,700 projects. And it used to take about 76 seconds in 2015 for us to be able to lose the solution. But now with VS15, we can do that in 15 seconds flat. Now, in addition to that, the open folder mechanism that I just showed you in Visual Studio Code, that's something else that we're also shipping inside VS15. And it's already there in the preview version. So what you're going to be able to do, what I showed you in Visual Studio Code, the exact same thing you can now do in Visual Studio as well. So the entry point of needing a project to begin before you start using C++ features in Visual Studio is no longer required. You can come up with the project that you have. It might be a makefile, it might be CMake, it might be something else. You can just click Open Folder, and we'll take care of giving you a code editing, building, and debugging experience out of the box. Now, something special we're doing for CMake here is that, how many people here have heard of CMake or use CMake? There's only one person there, so I'll cover this or 2 people there. I'll use this very briefly. Is that when you open a folder and we see a CMake list file, which is basically an artifact of CMake, we will go and analyze that and be able to drive the language service and debugger and the build experience from that. No longer do you need to go and bring up the CMake GUI and create a Visual Studio project and so on. We'll take care of that in the IDE itself. And that's all going to be the next version of the product. The last thing I want to cover here on the topic of Visual Studio is basically our new acquisition experience. When you're installing Visual Studio 15, you'll see a screen like this. And what this screen is basically doing is basically enlightening you guys about the new installation experience that's there as a part of VS15. And there are a few advantages of this installation experience. The first thing you'll see here is that your hard drive is going to thank us or thank you guys back, because this is going to be a lot less expensive from an installation perspective. The reason for that is because when you're going to basically choose the workload you want to install up front. So in this case, in this picture, you see C++ selected, which is going to install all the classic Windows development tools that you need for creating a classic Windows app with C++. So one of the things you'll see here is that the other thing you're going to see, besides the size of the install being much smaller, is that the installation will be a lot quicker. So I don't know how much time do you guys account or take aside for installing a version of Visual Studio. But if you just click C++ here and click Install, on an average machine, this should be done in about 15 minutes. So no longer do you guys have to wait for an hour or a couple of hours to install VS there. One of the last things I want to mention here as well is that if you look at the summary section on that slide, you'll see a list of optional components there. So sometimes people have 2 versions of Visual Studio side by side because they want an older compiler version and the newer compiler version. So what we've done here is that with this installation experience, not only will we provide you all the other things that I talked about, but we will also provide you the option to install previous tools as a part of this installation experience. So there's no longer a need to have 2 versions of Visual Studio side by side, or at least there's one less reason to have 2 versions of Visual Studio side by side. So if you guys, you should really try it out, and hopefully you guys will like it. Again, we're still open for feedback here. It's only the preview version of the product, but we would love to hear more here on this front. So that takes me to the last section of my talk, which is basically going to be about the different workloads that we have. The first workload that I just want to talk very briefly about is UWP or Windows. So if you create a UWP style of app, you can basically create one app that's going to target Windows 10 desktop, mobile, HoloLens, Xbox, and a bunch of other stuff. And the next thing I want to also mention on this slide is that we currently have 2 bridges for Windows Store. So if you're looking into taking your existing Windows, classic Windows application, and then convert that into a Windows Store application, you can actually look into Centennial. It's basically a story where we allow you to package your desktop app for the store. And the other story that I want to talk about very briefly here is Project Allenwood, which will allow you to take your existing iOS application and target Windows using the Allenwood project story that's there in the product. The next story that I want to get into very briefly is that how many people here know that Visual Studio also allows you to do mobile development for C++? So you can write an Android app, iOS app, all in one IDE. So that's something else that we've been investing in. And one of the things you'll see here is, one of the things we've done is that we've added a new story here for iOS development. They're actually linked. For iOS development. You can take an existing Xcode project, and then you can bring up and bring up this import from Xcode wizard, which will allow you to import your existing Xcode project into Visual Studio, and then you can start on top of that and start making your iOS application even richer from a C++ code perspective. Something else that we've done on an Android front is that we've added support for Java language and Java debugging, language service and Java debugging. We've also added support for more recent Android API levels, NDKs, and we've also added support for Gradle build systems. So this is all stuff that we've done within the last 1 year, and you guys should try it out. If you guys want to learn more, you can look at the link below. It gives you a pretty good story there. So I'm actually going to skip over this demo because I want to get into this section here. The second last section I want to talk about is about Linux development. How many people here have tried to write an app for Linux from Windows or today do any kind of Linux development in this crowd? I see a few hands there again. So what you can do is you can actually, have you played with the Linux story so far? Know anything about it? You have? OK, that's good. So one of the things that we're shipping for the rest of the people in the room is that you can also use Visual Studio now to not only target Windows and mobile, you can also target Linux and IoT from within Visual Studio. And currently in VS 2015 or Visual Studio 2015, this is present as an extension. So you have to go to the marketplace and grab this. But once you install this, what we allow you to do is we allow you to remotely compile your app and also debug that app from within Visual Studio. So let's go ahead and demo this very quickly. And that's a logo from Satya, where Microsoft loves Linux. I'm actually going to go back to 8. All right, so I'm going to demo here very quickly the Linux targeting story from Visual Studio. So for doing so, I'll probably bring up one of my pet projects here. So if you guys are getting started in Visual Studio, one thing you can do here for looking at any of the cross-platform stories, you can come in the cross-platform section, and this will give you templates to get started for Android, iOS, and Linux. So I already have a Linux app that I baked for this demo, so I'm actually just going to go and demo that very quickly. Here we go. It's a tic-tac-toe game, and it's fairly very simple. All it does is draws a board, and then players basically play against the computer or an automated machine. So what you need to do here is basically, once you create this template, all you need to do is you can bring up Tools option here again very quickly, and you can go ahead and define a connection manager here. In the connection manager, you can add the Linux machine that you want to operate against, or basically remotely compile this app or deploy this app to. Now, this could be any Linux distro. We support all of them. It could be the Windows subsystem story for Linux. It could also be an IoT device for that matter. And all you need to do here is basically provide you the host name, the username, password, and click connect. I already have this configured here on this Linux box that's running right here. As you can see, this is basically my Linux machine right here. So let's actually go and build this application. As I click build, you'll notice that, let's do rebuild here. As I build this application, you'll see that it actually goes and clears out any remote projects directory. And as you can see, there is a new projects directory getting created. All right, so as you can see here, it actually created a projects directory on my remote Linux machine. It actually created a bin directory where this app is. I'm just going to very quickly run this app. So all it's doing is basically, you're just playing against the computer here. And this is currently running on your Linux machine, but it was built from within Visual Studio via the remote build mechanism that we have. So not only do we support remote building, but we also actually support other features. For example, you can actually go ahead and set a breakpoint and then click launch from within Visual Studio. And what that's going to do is it's actually going to launch the app, and it's going to allow you to debug it from within Visual Studio. On the right side of the window, you'll see a window pin here called the Linux console window. This allows me to control the application from within VS while I'm debugging it. So actually, I'm going to go ahead and say, yeah, go ahead. Go to the next breakpoint. Finally, at this point, it's looking for user input here, so I can actually provide input here. And as you can see, once I provided input from my application, it went back to the next breakpoint that I had set. So what you guys can do is you can really try it out, especially for those guys on the side of the room who are trying out the Linux experience. If you want to be on Windows and still want to use the productivity of Visual Studio from a language service perspective, from a debugging perspective, this is definitely something you guys can try out. And we're only going to make this better. So moving back to slides, just a few more slides here. What I just showed you also works for IoT. So in one of the templates that's there in the File New Project menu, there's a Raspberry Pi template. You guys can also use that. And the same story works there as well for building and debugging. The last section that I want to get into is about gaming. So a lot of people here use Visual Studio for writing games, cross-platform games, or using game engines. How many people here have written a game or at least have something to do with a gaming operation? There's about a couple of hands there, I see. So one of the things you can do in Visual Studio that we worked upon recently is that we have some new game engine partnerships that we've done. So for example, Coco Studio and Visual Studio had a post recently which talks about how you can use Coco Studio, which is a popular mobile gaming engine for Android targeting story. Something else that we've done is that we're currently working with Unreal in order to be able to build their Android debugging story on top of our cross-platform mobile development story. So you can see here, there's a picture of Unreal 4 engine. I keep doing this, it keeps doing this to me. Unreal 4 picture, and this is basically debugging UE4. I've given up on that one. That was debugging UE4, and basically it's using an Android story. So you can actually go ahead and take a look at a blog. It's pretty popular on what's new there. The last slide that I want to just get into very quickly is that in 2015 timeframe, at Build, we basically launched this story about a dev lab about how you guys can use this to basically go update your builds or update your product from whichever product you're on from that one to 2015. And as a result, we've updated the MSDN documentation of that. On top of that, the next thing there that we also created a GitHub repo, VC samples, which basically provides a list of resources that you guys can use to update to the new version of VS. And lastly, even if you try out these two sites that I mentioned here, and still you find issues with updating to the next version of Visual Studio, you can directly reach out to us, and our team and our engineers in Redmond, Seattle, will be able to help you with that story. So just to summarize, this is the last slide that I have. Here's some of the things that I showed you guys today, and Casey as well. The first thing we talked about was the Visual C++ tool set. I gave you a picture about what's new with the backend compiler, the front-end compiler. We got into what's new with 2015 Update 3 and VS15. Let me just say this again. We're aiming and we want to be the most productive IDE for your edit, build, and debug cycle. And we've done a bunch of work there that I just showed you guys from a productivity perspective. Performance is key for us, and we want to make sure that that's addressed. In the upcoming VS15, you'll see a lot of work around performance, whether that's to do with faster installation, faster IntelliSense, faster building. All that is covered there. We also talked about a new tool that you guys can use, the cross-platform editor code, which you can use for editing your code, for building your application on other platforms which are non-Windows. And the last thing I want to just basically highlight here is the any developer, any app scenario. If you look at Visual Studio in this talk, what you'll see here is that we basically provide you to create an application for pretty much any platform. That could be Android, it could be iOS, it could be Linux, it could be a Raspberry Pi device, or it could be a game that's basically cross-platform. So you can bring up for any C++ developer, you should really look into Visual Studio and try this out. The last thing that I want to just say here on an ending note is basically we're definitely hearing out to all the feedback that you guys are providing to us on UserVoice, Reddit, VC blog, and some other channels. Keep doing that because that really helps us, and we're really listening with all the work that we've been doing. Thank you very much. That's pretty much the end of this talk. I'm happy to take a few questions if required. Thank you. I think these are some other slides there. You can actually evaluate the session using that. And is there any questions you guys have that I might be able to help with? Yes, sir. Is the PDB size still limited to 2 gig? That's. I believe you're still using Visual Studio 2013. Is that correct? I see. You should not see that in 2015. We've actually added a special switch, which is now actually a part of the default linker setting, where the PDB should not be limited to 2 gig anymore. We had some OS-related issues. I'm trying to remember now. It's been a couple of years. I think it was Big OBJ. I think if you pass it as a compiler switch, I think that creates that allows you to create a larger PDB size. But sorry, yeah. There's another question there. Visual Studio only 32 bits? Yes, Visual Studio is still 32 bits. There's a lot of discussion that's happened on a lot of channels on whether making it 64-bit is actually going to make it faster or not. But to answer your question today, it is still 32-bit. Is there any other question with the stuff that I covered today? Yes, sir.
I saw one of the slides you referenced that you discussed C++ CX without a projection for the window runtime?
Right.
So is that happening? Is that going to be what would the advantage of that?
I think the reference that I made on that one was to do with the Angular stuff that we've done recently for making OpenGL apps run on, OpenGL Linux and Mac apps run on Windows. So we've been experimenting with, people being able to create a UWP app without C++ CX. I'm not sure if I have the answer. What are the implications from a performance perspective are? Maybe we can follow up offline, and I can try to connect you with the right guys there. Does that answer your question, sir?
Yeah.
Is there any other questions in the room that you guys might have? All right, thank you very much. Have a good day. I hope you guys enjoy Ignite and get to do some sightseeing as well here in Atlanta. Thank you. Thanks, man. Thank you.